All right, we're going to take a look at the area between two curves. And I've got two general formulas up there. And we'll get some diagrams up here to kind of help it make a little more sense. Area between two curves, integral from a to b of f of x minus g of x, think top minus bottom. Or integral from c to d, f of y minus g of y, dy, think right minus left. Now, I'll give you a few diagrams as far as looking at this, but what we want to remember is evaluating the integral. It's either an easy integral or it's not. We can evaluate the integral. We're going to use our calculator to evaluate the integral as far as putting that in and getting a value. The key is going to be in the setup. So we've got to focus to make sure we're getting the setup correct. I'm going to give you a few diagrams here. We're talking about an area between two curves. So let's see here. A little bit better marker. Let's go with, all right, if I'm going to say that this is F and this is G. So here is A, here is B. So if we're going to find this area between there, that's why I said top minus bottom. F is on top of G the entire time. So we're going to have this F function, whatever it is, minus whatever the G function is, between A and B creates that integral. Now these are generic forms when I say F minus G. Sometimes G would be on top. So here's another look as far as a diagram. Let's say there's G of x, and here's F of x. There's A, there's B, and I want this area. The way I would write this one would be integral from A to B of G of x minus F of x dx. So again, I just got to make sure I know which one's on top. The generic form always shows, well, F's on top. Well, it might not be on top, right? So think top minus bottom, whichever one it is. And it's possible that the function that begins on top ends up on the bottom in another part. So in other words, they cross over. Maybe something like this. Give you a different look here. I'm going to get this guy being F of x. And I'll make the purple one here G of x. And our limits would be, so we're going to go right in here. We'll say that's A. We'll say that's B. And we'll say that's C. So they switched over. F was on top in the first half or first part. And then G flipped to being on top in the other part. That's fine. It just means that I'm going to have to create two separate integrals. I'm going to have one integral from A to B, and then another integral from B to C flipped over. So here's what my integral would look like. Area, integral A to B, F of x minus G of x dx, plus the integral B to C, G of x minus F of x dx. So I have to create two separate ones. So in short, I've got to know which function's on top. I'm going to list that one first. If it doesn't stay on top the whole time, I'm going to have to set up two different integrals. If it does stay on top the whole time, remember this one was the original, then I'm good to just kind of stick with that one integral. Right minus left. All right, now I've got F of y and G of y because this is typically referring to graphs that are not functions. They don't pass the vertical line test. So something that would be a right minus left, give me a picture here. So this would be a picture for this guy right here. So this would be F of y, G of y. Say that's D, and again, these are just numbers, C and D. So we're looking for this area right here. And obviously when you look at it, F is not on top of G and G is not on top of Y, or G is not on top of F. But F is clearly on the right side of G. So right minus left. This function minus this one. And we're going to look at all kinds of different setups here. But I'm either going right minus left or top minus bottom. Now this is our beginning piece as far as area. We're going to get into some concepts of area in multiple forms, surface area, arc length. We're also going to do a lot of volumes. We're going to just make something revolve around an axis. All of that comes back to this, top minus bottom or right minus left. That's going to be my focus here with the area. I've got to make sure I'm getting the setups correct. If I get really good at recognizing the top, bottom, right, or left, then it's going to help me going forward. So let's get a few functions up here and kind of look at these different setups. Let's say I want the area bounded by y equals x squared and y equals x cubed. Y equals x squared and y equals x cubed. So on the area that's kind of trapped in between, you have a couple of options here. You could graph these two equations on a calculator and see where they're crossing or which one's on top or on the bottom. You could also, if you're wanting to know the intersection, you could set them equal to each other because they're both equal to y. Right, so if I wanted to know the intersection, I'll say intersection points, x squared equals x cubed. Let's see, so zeros, x cubed minus x squared. I can factor out an x squared, x minus 1, so that means x is 0 or 1. So that would be the intersection values for that 0 to 1. So I know my area setup is going to be the integral from 0 to 1 because that's where they're bounded. If they're intersecting at x equals 0 and 1, then the area I'm talking about is between those values. Which one's on top? Well, x squared in this case is the one that's on top. So I have x squared minus x cubed dx. Now, how do I know x squared's on top? Well, I have a couple of options here. Number one, I could look at a graph on my calculator or think of the graph. This one's not a bad graph to look at. You know, here comes x squared, it's a parabola. I'll just do kind of a dotted line. And then here comes x cubed as that cubic piece. So we're looking at this guy, there's one, looking at this piece right here. That x squared is on top. Now, another thing that's kind of troublesome sometimes, especially in this case, is they get really close together. So telling which one's on top might be a little bit difficult. Zooming in on a calculator, very detailed in your graph. Another thing that can help is a lot of times I just try a point. Okay, if they're intersecting at 0, 1, and that's the only places they intersect, then that means between 0 and 1, one of them's on top the whole time. Because if they switched over and crossed, I'd have another intersection point. So I'm just going to pick a value in there, and I'll pick a half. It doesn't have to be right in the middle. I can do any value between 0 and 1. But a half squared is a fourth. A half cubed is an eighth. So again, a half squared is a fourth. Half cubed is an eighth. I picked a half because it's in the interval. 1/4 is bigger than 1/8. That means that x squared's got to be on top because that y value was larger. That's giving me my setup. Now from this point, I know my answer is going to be 1/12. I know that because I'm cheating. I wrote it down. But two ways. I can integrate it by hand, or I can put this in my calculator and get the 1/12, which my calculator would give me the decimal value. See what that is, 0.083. And I'm fine with the decimal as far as looking at that. What I want you to focus on is getting this piece. Okay? You know how to integrate by hand, so that's not our focus at the moment. Our focus is getting this piece right here. We need this guy set up correctly. If we can set that up correctly, it'll make things a lot easier going forward. So that means for evaluating the integral, I want you to use your calculator. And it's probably going to give you a decimal fraction. I don't care about that. Use your calculator to evaluate the integral. You can tell if you got the answer correct. One of the things that usually is an obvious sign, we are computing area. Now, integrals are used for a lot of things, but we're computing area this time. Area is positive. So if I ended up with a negative over here, that probably means I had those two reversed. I had the wrong one on top. So again, focus on the setup. Don't take the time to just grind out the integral. I want you to use your calculator so we can make sure this is correct. Our focus is going to be on that setup. All right, sometimes, I'll give you a couple of different looks here. I'm asked about area, bounded. Sometimes I'm given an interval by y equals x squared minus x and y equals x cubed on 0 to 1. So this time I'm given an integral, or an interval, not integral, given an interval. So I know already I'm going to go from 0 to 1 bounded between those two functions. Okay? So I didn't have to go through this and find an intersection. I still have to figure out which one's on top. So again, you're back to the graphing idea, or you can try that point. I'll usually try the point. If I did a half squared is a fourth, minus a half, that would be a negative fourth. And then a half cubed is an eighth. So an eighth is bigger than a negative fourth. That means this guy's on top. And then we're subtracting the bottom one. So the key is make sure you use parentheses, because we're going to have to either leave the parentheses in there for our calculator or distribute it through. On my model calculator, I don't typically like the parentheses in there, so most of the time I will actually go ahead and distribute the negative so it's out of my way. And you can check this on your calculator. I got 5/12. So again, our focus is this. Go through on your calculator. If you need to pause the video to make sure you're getting that correct on your calculator, do so. But we want to make sure we remember how to enter these on the calculator to get that value. And again, I wrote the fraction form, but don't care if it's a fraction or decimal. That's not going to make a difference there. Another look here. Let's go bounded by x-axis, x equals 2, and f of x equals x cubed minus 2x squared plus 3. X-axis, x equals 2, and x cubed minus 2x squared plus 3. So this would be one where, you know what, a little bit different sketch. Maybe I do want to kind of know what this thing looks like. So if I graph this, helps if I'm in the right mode here. All right, kind of give you just a generic graph. Minus 2x squared plus 3. Minus 2. Helps if I can type it in right most of the time. All right, that looks good there. All right, so I'm looking at something like this. So I've got a graph. This isn't going to be a perfect sketch, but I don't need anything perfect to figure this out. There's 2. And then I'm hitting right here at negative 1. All right, so, and of course it goes past that. Just to kind of give you an idea, I only cared about between the x-axis. So here's my x-axis. And this function, There's my function. And it's bounded by x equals 2. It didn't give me a left bound because it's actually going through and hitting at -1 for that piece. So I know that's going to be where the interval is, -1 to 2. I could also set this equal to 0. See where it connects to the x-axis. If I set that equal to 0, I'm going to get a couple answers. I'm going to get 2, and then I'm going to get -1 as far as for solving that piece. So now let's take a look here. My setup, -1 to 2. So what I want to remember is x-axis. That is another function. Remember, this is f of x or y equals 0. So that is the other function. And that's the bottom function. So I'm going to have x cubed, my top function, minus 2x squared plus 3 minus 0. All right, now let's take a look at this. I put parentheses around it to indicate I've got that whole top one, that x cubed minus 2x squared plus 3. No, I don't really need them there, but it's going to help me in the future. And then minus the 0. No, I don't need the 0 there. However, at this stage in the game, I would encourage you to always put the zeros in. If you go another step and eliminate parentheses and the 0, you'd have that. But I would suggest putting them in because it reminds you to subtract out the bottom. You've got to subtract out the bottom. And I know the bottom's 0 here, but we need to kind of keep in mind it's always top minus bottom. That means there's always a top, there's always a bottom. We'll get to one like this in a minute. There's always a right, there's always a left, even if it's 0. That's what'll help you. Now this one, if you put in your calculator, you should get, let's see, about 6.75, I believe. That's what I had if you put that one in your calculator. But the key is to focus on the zeros. Focus on the zeros, get them in there. I know it seems kind of trivial at this point. It's going to pay off on the next few lessons, having that 0 in there. Just to remind you that there is that bottom piece. Let's go with a different one. Let's go area bounded by f of x equals x squared. And g of x equals square root x. So now we're back to similar to the first one where I'm not given any kind of an interval. So I've got to go figure out the interval. Right? Again, if you think of a graph, a parabola, here comes that square root. Looks something like this maybe. Here comes that parabola. Here comes the square root. And I'm not really positive yet without looking at a detailed graph, but I'm pretty sure the square root would be on top because if it wasn't, there wouldn't be an intersection if it was sitting down here below. So here's how I can definitely look and figure out those intersections. I can look at a graph, and that would actually be the point 1. That's the point 1, 1. So I'd have that 0 to 1, or I can set these equal to each other. If I set them equal to each other and solve, I would get that 0 or 1. I'd get either one there. So just kind of take a look at that. If x squared equals root x, x to the 4th equals x. If I want to get rid of the radical, I can square both sides. I'll bring it over, factor out the x, and there's my 0. And there's my 1. All right, so that x is 0 and 1. So a lot of 0s and 1s here because I'm just trying to keep the numbers a little bit small for us on the examples. Now I've got 0 to 1 to x. Now the question comes in, well, which one's on top? Is it going to be the square root or is it going to be the x squared? And this is where we can go through and kind of look at and test a value, again, like a half. Half squared is a 4th. Square root of a half. Square root of a half would be a larger value there. Square root of a half would be 1 over root 2 or root 2 over 2. and that is a larger value than a fourth. So it had the square root of x minus x squared dx. That would be my setup. I know that one's on the top. And then my answer I've got here is 1/3. So you can test that on your calculator. You should get 1/3 or 0.3. All right, now I'm going to look at one that's going to be the right minus left. So if I have what we call a horizontal representation, if I said area bounded by x equals 4y minus y squared and x equals 2y minus 3. All right. Now, usually when you see it x equals something, so you've got the y's in there, that's going to generally indicate you've got functions of y. Remember, I can rewrite x as f of y because those are just y's in there. So that's indicating that right minus left. Okay. Sometimes you have functions where you could go solve for y and turn them back the other way. Like this one you could solve for y, but yet you're kind of stuck on that one and can't solve that for y. So here comes my setup. I need to figure out where they're intersecting first. So they're both equal to x. 4y minus y squared is 2y minus 3. Now these are a little tougher to graph because they're not as familiar with graphs to us. Let's see, I'd rather have, if I got a square, I'd rather have it all on one side. So 0 is y squared minus 2y minus 3. I can factor. Y minus 3, y plus 1. All right, we got y is 3 or negative 1. Y values now. So I've got y limits. I'm going to have y's inside and a dy on the end. So here's my setup. Area, negative 1 to 3. Remember, lowest to highest. So negative 1 to 3. Now, since I'm in y's, it's right minus left. I'm not thinking about which one's on top. I'm thinking of which one's on the right side. Okay, so either the parabola, I know it's a parabola, or the line is sitting on the right side. And in this case, the parabola is on the right side. So 4y minus y squared minus 2y minus 3. So now a couple things here. There's my setup. First off, all right, how do I know the parabola is the one on the right? Well, what I'm doing is I'm just remembering if it's a negative y squared, it's got to look something like that. It's got to be a parabola coming back left. And then the other one's a line. So the only way that it's going to have an intersection or a closed off region would be if the line's over here. If the line was over here, there's nothing closed off. The line would have to be on that left side, meaning the parabola's on the right. Now, how well do you remember some graphs like that? I don't know, and it really isn't going to matter because remember how we could test a value. What's an easy value between negative 1 and 3? 0. 0 would work. Anything between negative 1 and 3. So let's put 0 in for y, because these are y limits. I get x is 0. And if I put 0 in for y here, I get x is negative 3. So 0, negative 3. Which one's on the right side? Think of a number line. 0 is on the right side of negative 3, which is going to push that parabola there. Second thing, notice I use parentheses because I'm making sure I've got my functions, especially when I've got a minus here in these formulas. I'm going to have to distribute sometimes, which this would be a perfect case. I could use my calculator from here. Or I've already told you I don't really like using the parentheses if I don't have to on my model calculator. So for me, usually I'll just distribute to the negative y squared plus 2y instead of 4y minus 2y and then plus 3 dy, and that's what I'm putting in. The other thing that you'll notice there, and we get my answer up here, this should give you 32 thirds. Or I guess 10.67. The other thing you notice is the fact that there's y's up there and not x's. It does not matter to your calculator what variable it is. So I would enter this equation just like I entered this one. So that x variable key you used for this guy is the same one you're using for that guy. It doesn't care if it's an x or a y when you're inputting it. So I have what we call x variable. I think most of those 83s, 84s have, I believe it's an xt theta in some key like that. Wherever you're pushing this x, use the same one here. It's not changing anything. It doesn't care what variables are used. So this will be an indication of right minus left. Notice, same thing. I got to figure out an intersection point. And then I've got to figure out which one's on the right. If it's a graph I know or can figure out, great, I can do that. I can think of the graph. If not, I can try a point. And it doesn't matter what point you try. It's any point in the interval to tell me which one's on the right side. So again, I picked 0 before. Let's say I pick 2. Right? 2's in that interval. That would be 8 minus 4. That's 4. 4 minus 3 is 1. So what's on the right side? 4 or 1 on a number line? 4 is on the right side. There's that parabola coming first. I can always test that value. I know that they did not intersect again in that interval. If they did, I would have gotten another intersection point right there. That's how I know they didn't cross a second time. Now let's look at one. I'm going to go back to this guy and look at one with x's. We're going to look at one that actually crosses in more than 2 places. So let's say area between, I'm just going to say bounded by f of x equals x to the 4th minus 4x squared. G of x is x cubed minus 4x. Bounded by those two. Now these are 2 graphs that I can't just, I got my calculator. I can definitely graph on my calculator and look. But as far as just general knowledge, well, it's not a basic parabola or cubic or anything like that as far as going through that origin. So I'm trying to think of, all right, what would these look like? I really don't need to know exactly what they look like. What I need to know are the intersection points. So where x to the 4th minus 4x squared actually equals x cubed minus 4x. I need the intersection points, and then I need to know which one's on top. Top, I mean x's. Here we go. X to the 4th, get them all on the same side here, minus x cubed minus 4x squared plus 4x is 0. And let's see, I can factor an x out of all of them. So x cubed minus x squared minus 4x plus 4, 0. Now I've got my x out there. I've got to solve that other part. And let's see, I could do some grouping. X. Let's see, if I group the first 2, I can take out an x squared, x minus 1, minus 4, x minus 1. So we'd have x. Take out an x minus 1, leaves me x squared minus 4, and that actually factors into x plus 2, x minus 2, but this still gives me my x values of 0, 1, negative 2, and 2. I have 4 different intersection points. And when I have 4 different intersection points, that means this thing could be switching around which one's on top. Now, when I write them like that, it's typically easier for you to, well, you definitely have to think of them in order. It might be easier for you to write them in order. I'm just going to rewrite them up here. Negative 2, 0, 1, 2. Because if I'm thinking of that x-axis or that number line, that would be the order they're in. You don't have to rewrite them. But either rewrite them or at least think of the proper order, because your first interval is going to be from negative 2 to 0. Your second interval is going to be 0 to 1. your third interval is going to be 1 to 2. So I'm going to be between -2 and 0, and I need to know which one's on top. They intersect at 0 and again at 1, so I need to know which one's on top there. They intersect again at 2, at 1 and 2, so I need to know which one's on top between 1 and 2. And I just have to take them one at a time. Okay? If I look at a picture or something, maybe one of these stays on top the entire time. If it did, then I could do -2 to 2 for the interval. It stayed on top. So let's just kind of look here. Let's take a -1. Again, just picking a number in the interval. -1. Let's see, that'd be 1 minus 4 is -3. -1 plus 4, that's 3. So 3 is bigger than -3. G's on top. So I'd have x cubed minus 4x minus x to the fourth minus 4x squared dx plus, going to the next one now. So I've determined in the first interval which one's on top. Now I'm going to go to the second interval, see which one's on top. Looks like I got to go with a half, and I'll cheat a little bit. Let's see, 0.5 to the fourth minus 4. All right, if I put 0.5 in, this one gives me -0.9375. And this one gives me -1.875, so that one's the bigger one. X to the fourth is on top. So the second one, I'm going to put the fourth power one on top. Cube 1 second, dx, now plus the third interval. So from 1 to 2, I'll test a 1.5. And test each one. A lot of times you can't just assume that it's going to switch all the time. I believe this one does. Yeah, and this one, the cubic's on top. That's the bigger value. Now, at this point in the game, this would be the most complicated one we're going to see at this point. But the nice thing is from here, you can evaluate those 3 integrals all on your calculator. You can evaluate those pieces on the calculator. You don't have to do them all by hand. But still, it's that setup. I got to figure out an intersection point. If I have more than 2 intersection points, that means there's a chance they crossed. I say a chance. Okay? These did cross. But if you had a graph something like this, it's a little bit different. There's the purple one. Here comes the green one. And yeah, they intersected there, but they didn't cross. So I wouldn't have to split this up to 2 integrals, because I can just go from this point to this one, because they didn't change places there. All right, so I still have to check. Goal is top minus bottom, right minus left. I didn't jot the answer down for this one as far as the value, but we're following that same process. Top, bottom, switch to here, top, bottom, switch, and then went top, bottom. They switch places on those pieces. We've got, our focus is the setup. Let your calculator get the values. Focus on getting that set up correctly.